Okay, so now you're ready for part two, and you should have gone through at least a little bit of that chart of the functional groups to look through some of those groups so you have a sort of feel for it now. Today we're going to talk about the 4 easiest functional groups to identify. The first one are the alkanes. An alkane is any compound that has all carbon-carbon single bonds. Nothing else. This is all carbon-carbon single bonds. Now, when we're saying this, we're implying that all of the H's are factored in. Let's talk about what I mean about that. There are 2 types of alkanes. The first are the acyclic alkanes. Acyclic means not in a ring. And they have the general formula CnH2n plus 2, where N is any integer. So for example, if your chain has 6 carbons, that means that you will have 14 H's. Let's talk about that. If you have a chain of 6 carbons, you will have 14 H's. All of your carbons have to have H's surrounding them so that they can have 4 bonds. So if we were to add up, or if we were to place all of the H's, the hydrogens, around each of these carbons, after counting them, there will be 14 of them, as per that generic formula. You can count them, there are 14. Now, the best way to write this compound in a formula is to use the line angle formula. Done. The line angle formula assumes that you have all H's around each of your carbons so that each of the carbons has 4 bonds. When you have all H's around all of your carbons, this is known as saturation. Saturation is the chemical way of saying that you have the maximum number of H's possible. In the same way that saturated oils have the maximum number of H's, we'll talk about that in a few minutes. Okay. The second type of alkanes are the cyclic alkanes. That means that there's a ring somewhere in the compound. And the formula for cyclic alkanes is CnH2n, where n is any integer. Now, because you don't have a maximum number of H's here, these are unsaturated compounds. And like I said, we'll talk about the connection between saturated in foods and saturated in chemistry in just a little bit. So, these cyclic rings either come in rings of 6, C6H12, or in rings of 5 carbons. Those are the 2 most stable forms of cyclic alkanes. This is how you draw a 5-member ring. This is how you draw a 6-member ring, pentagon and a hexagon. Get good at drawing a hexagon. You'll need to know how to do that. Also notice that I don't draw it like a house because you want all the bond angles to be the same. So please don't draw like a house. Takes a little bit of practice to draw so that it looks nice and you're not scribbling all over your paper, but try to be as accurate as you can and as neat as you can be when you're drawing these compounds. Okay, so we're going to be spending a lot of time in the organic section talking about compound nomenclature. Remember that nomenclature just means a systematic form of naming. And the reason to get good at naming the very different types of organic compounds is to help you identify, when you get into your nursing practice, some of these organic compounds that come up. Now, we're not expecting that you're going to be able to look at a super complex drug that has probably 70 or 80 different atoms just in it and be able to name it. That's not what we're looking for. We're just looking for a basic understanding of the system and how you could translate that into your practice. Okay, so let's talk a little bit about nomenclature. Now, I know some of you had a hard time with nomenclature for all the different types of compounds in general chemistry. If you had a hard time with that, you will have a hard time with this. However, I don't think that a lot of you, when you were working those problems in the homework, were going back and looking systematically at the rules. If you do go back and systematically look at steps 1, 2, 3, 4, and so on, you won't be able to answer any of these questions incorrectly. You should get right answers every time. So please make sure that you either you print out these notes and have them sitting next to you while you're working the homework, or write them down in a different way if my handwriting bugs you, or if it bugs you that it's on the smartboard or in the PDF format. Write it down on a separate paper or on note cards so that they're easily accessible to you, so that you can practice the concept and get good at it. Nomenclature is easy and it's fun. It's fun because it's great to be able to write a name for a really complex compound. It makes you feel smart. And it's easy because it's the same for everything. So if you just follow the rules, you should have no problems. Okay, so let's talk specifically about, in general nomenclature for all compounds. We have to know 3 different terms. The first is the prefix. The prefix is where we put what are called substituents. The substituents are anything that is not those implied H's. Okay. Now, the second group after the prefix that we need to know about is called the parent group. The parent group is the most important group for starting out with naming of the alkanes, and this is the carbon chain. So whenever I refer to the parent group, that means the carbon chain. Now, there's a trick to this. You're always going to want to identify the longest carbon chain, and you'll see on my homework that the longest carbon chain isn't always the one that's going horizontally across. Not the horizontal one. I'll just write that so that you can try to avoid my tricks. And then the third group is the suffix. And the suffix is going to tell you, for all of the nomenclature, for all the different functional groups, for all the organic compounds, the suffix is what tells you, it identifies what type of functional group you have. The fun thing about nomenclature in organic chemistry is that just by looking at a compound's name, you can tell what type of functional group it has in it. And the whole process is the same for everything, and it's great, it's easy, and it's fun, and I don't think you should have any problem with it. Okay, so the prefix is whatever is in the beginning. That's where the substituents are, anything that's not those implied H's. The parent is the carbon chain, and this is usually some a number of carbons. We'll talk about that in a bit. And then the suffix is what identifies the functional group that's in charge. Okay, so let's talk specifically about naming for alkanes. Got a sun glare in there, I apologize. I'll try to avoid it. Step 1 is to identify the number of carbons in the longest carbon chain. In order to have a carbon chain, you must have all carbons in a row, not broken up by any other type of element. Okay, so let's just do an example here. How many carbons do you have in your longest carbon chain? You have 7. You said 6, it's because, or 1, 2, 3, 4, 5, 6, 7. Yes. There are 1, 2, 3, 4, 5, 6 bonds, or 6 lines, but remember there are 7 points. So in this example we have 7. Okay, now we need to identify the prefix that goes with the number. Okay, so let me just write a new table for each of the numbers. There are 10 numbers that you should know and have memorized. I'm sorry I didn't do this beforehand. Okay, so we have I'm going to have to pause it. I'm so sorry.